Good morning, everybody. Happy Monday if you're watching this on Monday or maybe Sunday night. But either way, happy Monday. And let's just get right into it. We're going to do some trig ratios, but this time with radicals. So let me get this focused. There we go. Well, let's just start out with number one. Well, you know what? No, wait. Before I start, I want to do a review. So let's just recall a few things. Okay, I want you to recall simplifying radicals. Remember, if we have something like the square root of, let's say, 20, we know that that is root 4 times root 5. So our solution would be 2 root 5. Okay, keep that in mind. Also keep in mind how you simplify fractions with radical denominators. For example, okay, so this was our first recall. Our second recall, suppose I have 3 divided by the square root of 8. Okay, I need to simplify this. I cannot have a radical in the denominator. So we need to rationalize the denominator. That means get a rational number. This is not rational. We want to get a rational number in the denominator. So, a couple ways I could do this. I'm going to show you 2 ways. First thing we can do is multiply by top and bottom by a number to make the denominator a perfect square. 8 times 1 is 8, not a perfect square. 8 times 2, 16, that is a perfect square. So I'm going to multiply top and bottom by root 2. So we have in the numerator 3 root 2 over 8 times 2 is root 16. Now, the denominator will stay 3 root 2. The square root of 16 is 4, and this would be our simplified answer, 3 root 2 over 4. The 2 and the 4 do not cancel. The 2 is under the radical, the 4 is not. Those 2 don't cancel. You could only cancel if the 3 and the 4 canceled, and they don't. So that's our answer there. Back in number 1, this was our answer. Okay, number 3. Suppose I have something like, I don't know, let's say 5 over the square root of 96. Okay, now that's a pretty big number. Now 96 times 1 is 96, 96 times 2 is, that's going to be almost 200. Here's an approach that I'm going to take with this one. What I'm going to do is simplify the denominator first. So I'm going to look at root 96 like I did root 20. I want to see if I can simplify the square root of 96 first. So let's just see. Let me turn this on. I'm going to do the rainbow method. What the heck? I've got 1 and 96. Let's see. I know 96 is divisible by 2. And I get 48. Okay, 48 is not a perfect square. 96 divided by 3 is 32. So I have 3 and 32. 32 is not a perfect square. 96 divided by 4 is 24. So I have 4 and 24. Okay, now 4 is a perfect square, but it may not be the largest perfect square. Let's just keep trying. I'll see if 96 is divisible by 5. Well, it's not. Okay, 96 divided by 6. Let's try that. 96 divided by 6. And I get 16. Okay, so also 6 and 16. Okay, so 16 is a factor of 96, and it's the largest perfect square factor. So I'm going to write this as 5 over. The square root of 96 splits up as root 16 times root 6. Okay, just to make sure, if I do 16 times 6, I do get 96. Okay, now, this is 5 over. The square root of 16 is 4. So my denominator is 4 root 6. Now to rationalize my denominator, I'm going to multiply by something so that 6 times that number is a perfect square. 6 times 1 is 6, not a perfect square. 6 times 2 is 12, no. 6 times 3 is 18, no. 6 times 4, 24, no. 6 times 5 is 30. No. 6 times 6 is 36. That's what we're going to do. Multiply top and bottom by root 6. So my numerator becomes 5 root 6. My denominator is 4 root 6 times 6 is 36. Now this becomes 5 root 6 over 4 times the square root of 36 is 6. So that becomes 5 root 6 over 6 times 4 is 24. So that's how that would simplify. You cannot cancel because the 5 and the 24 are not divisible by any common number. Okay, so keep that in mind, and we're going to roll that in with finding trig ratios with radicals. Number 1. For this one, they're going to give you the right triangle on Delta Math, and I believe for all of these problems, it's triangle ABC where C is your right angle. Okay, BC is 5, BA is 15, and CA is the square root of 200. Okay, the problem is going to say, find the exact value of sine B in simplest radical form. Okay, so keep in mind SOHCAHTOA. SOHCAHTOA. So the sine of B, here's B, so the sine is opposite over hypotenuse. Opposite is the square root of 200. The hypotenuse is 15. Now this is not simplest radical form, so we need to rationalize, or not rationalize, I apologize. We need to simplify the square root. Root 200 splits up as 100 times 2 over 15. The square root of 100 is 10, so I have 10 root 2 over 15. Now I do notice that the 10 and the 15 are both divisible by 5. So if I do 10 divided by 5, I get 2. If I do 15 divided by 5, I get 3. So my final answer for the sine of B in simplest radical form is 2 root 2 divided by 3. And that's going to be your final answer. Okay, now you might want to put, when you do your answer in Delta Math, you might want to put 2 root 2 in parentheses and then divided by 3. And then hit enter. Reason being, if you just do 2 root 2 divided by 3, it might just do the root 2 divided by 3. I'm not quite sure how it's going to interpret. Well, actually, that would be okay. Okay, let's just circle back. You can probably enter it like this, but if you're having problems, try putting it in the numerator. Or try putting parentheses around the numerator. Okay. All right, next one, number 2. Another right triangle. Similar setup. Here we have 8, here we have 2, and here we have the square root of 68. Find the exact value of, and by the way, this is an exact value. It's not a decimal approximation. This is exact. Okay, again, we're going to find the exact value. For this one, we're looking for the cosine of B. Okay, here's angle B. The cosine of B is the adjacent over the hypotenuse. So adjacent is 8 over the hypotenuse is root 68. Okay, we need to simplify this. Now I notice that 68, let's just think of the factors of 68. Well, let's look at it this way. Instead of using the rainbow method like I did over here, writing down the factors. Let's try it this way, where I look at our perfect squares, 4, 9, 16, 25, 36, 49, 64, and so on. Okay, I know that 68 is not divisible by 64. 68 is not divisible by 49. It's not divisible by 36. It's not divisible by 25. So none of those work. Let's try 68 divided by 16. Nope, not divisible by 16. Let's try 68 divided by 9. Well, you already know it's not going to work. Let's try 68 divided by 4. That works. 4 times 17. So first, I'm going to make this 8 over the square root of 4 and the square root of 17, because we just figured out 4 times 17 is 68. So I'm going to split that up like that. Okay, now the square root of 4 is 2. Square root of 4 is 2, and then I still have a root 17. Okay, to rationalize the denominator, I have to multiply by root 17. Root 17 over root 17. So that's 8 root 17 over 2 times, well, root 17 times root 17, you know that it's going to end up being 17. If you did 17 times 17, you get 289, and the square root of 289 is 17. That's why we chose it. So I have 8 root 17 over 2 times 17, and we know that's 34. Now I see that the 8 and the 34 are both divisible by 2. 8 divided by 2 is 4. 34 divided by 2 is 17. So my final answer here, the cosine of b, is 4 root 17 over 17. Now again, the 17s don't cancel. One's under the root and one is not. Do not cancel those. Leave it like that. Okay, number 3. This is our last one. Again, A, B, and C. BC is the square root of 13. BA is the square root of 22. And over here I have 3. Okay, let's find the tangent of A. Here's angle A. The tangent, remember, is opposite over adjacent. So with respect to angle A, I'm going to move this up a little bit. I apologize. There we go. With respect to angle A, the opposite is root 13, and the adjacent is 3. With respect to angle A, opposite and adjacent, root 13 over 3. Okay, there's nothing more to simplify. Root 13 is prime, it won't simplify. I don't have a radical in the denominator, so I don't have to rationalize the denominator. So the answer for this one is simply root 13 over 3. Okay, all right, that takes care of that. So I want you to just practice this, and let's see if we can find something for our golfers out there. Once you get these problems done, that will be a boom, hole-in-one. Nice job. Way to go. Have a great day. And if you have any questions, of course, always email me, and I will talk to you tomorrow. Okay, bye-bye.